Hey everyone, my name is Matt Bennett, and welcome to a breakdown of the Wwise implementation of my undergrad capstone project, Project Echo. Before beginning any audio work on the project, I made sure to create an asset sheet to keep organized, with these three main audio pillars to guide the audio vision of the project: otherworldly and mysterious, sound drives gameplay, and realistic sound behavior in an unrealistic environment. Here we have the music section of the asset sheet, where I first established a naming convention, gave descriptions of the music layers, and laid out detailed implementation instructions for myself. Additionally, there's also a status column to help keep track of what needs to be worked on, as well as different priorities that I can assign in order to help myself stay organized. For the sound effects part of the asset sheet, I adopted the same principles as the music section, with some sound effects specific tweaks. These include how many variations of each sound need to be made, the spatiality, and whether the sounds should be made in mono or stereo. The project has a brief amount of voiceover as well, so I made sure to include a VO page on the asset sheet. And here I have a page to keep track of audio bugs within the project, and finally an audio terms dictionary, which can be helpful when collaborating on a cross-disciplinary team. Now I'll dive into the compass in Project Echo, arguably the most pivotal sonic and gameplay element of the project. The player can summon the compass to their hand at any time by pressing the trigger on the right hand. Let's take a listen. To create this adaptive audio system with the compass, I first started by defining a dictionary. The keys of the dictionary are composed of all the different keys which the compass sound can randomly choose to play in. The values of the dictionary correspond with their matching keys and are named identically to corresponding switch values within Wwise. Here, I use the AK post event method to start the music switch when the game starts. When a compass event is triggered, the corresponding Wwise event is posted, with two different callbacks being created of types AK end of event and AK marker. These in turn fire the onCompass event finished function, which handles the switching of states based on which compass sound plays on a particular activation. Using the setSwitch function, the switch value is read as string and sets the corresponding switch value in Wwise as a result. And here an update, using the hasTriggered bool which we set in the earlier functions, player input is disabled until the compass event is complete, protecting against unwanted stacking of events. Now let's crack open Wwise and take a deeper look at the compass itself. The compass sounds are held in a blend container, composed of a random container as well as an additional sound which acts as a bed of sorts to the random container. The random container contains 30 different possible compass sounds, all with their corresponding tonalities labeled within the file name. To make the seamless switching system possible with the switch group, I put a marker at the beginning of each compass sound, corresponding exactly to the different keys we saw earlier in the dictionary. These markers are used to access the dictionary in the script, letting the setSwitch function properly and seamlessly set the corresponding state for the switch group. For the music system, I opted to utilize a Subtracks-based approach, with each subtrack being set to switch type and matched up to the corresponding association. The music system is divided into 3 layers, with the first, a synth bed, immediately starting upon the player first activating the compass. The second and third layers, composed of string pads and a more driving synth layer, all follow the same switching system, but are completely turned down until the corresponding music layer's RTPC reaches the correct value. We'll come back to the music layer's RTPC setup shortly, but first let's take a listen to the switching system in action. When the switch state is changed, you can hear the drone update to match the root note of the new tonality. And the compass sound always matches whatever the particular key is at that moment. Taking a closer look at the RTPC setup of the project, here are the RTPC curves for the strings layer, with a high-pass filter and 2 voice volume curves. The high-pass filter and first volume curve correspond to the music layer's RTPC, bringing up the voice volume once the player has progressed far enough. The third RTPC curve is linked to a separate RTPC, reveal status. This RTPC is linked to whether the player is currently revealing their environment with the compass, resulting in an effect where the strings come in and out dynamically with the visuals. The RTPC setup for the more active synth layer is very similar, only missing the reveal status RTPC. Let's take a listen to the music layers in action. Here's the crystal pickup function, which is placed on the orange and blue crystals that you just saw placed in the game, which increments the music layer's RTPC for each crystal that the player acquires by calling the corresponding Wwise events. Next, I want to dive into the dynamic, collision-based audio system of the project, in this case utilized on metal barrels. Within the barrel impact switch in Wwise, there are 2 random containers, each containing 5 variations of light and heavy impacts respectively. Each random container is also set to have random variation on pitch and volume, helping to create even more sound variation. To dynamically switch between the light and heavy impact states for the barrels, my barrel behavior script utilizes an on-collision enter function, which immediately takes note of the linear velocity of the barrel upon receiving a collision. This velocity value is fed into the barrel impact velocity RTPC and compared against a speed threshold check to determine whether the impact the barrel received is light or heavy. Depending on the result, the barrel state is set and the corresponding impacts random container is played from Wwise. Once again, my name is Matt Bennett, and I hope you enjoyed this breakdown of the Wwise implementation of my project, Project Echo. Thank you so much.